To introduce to you to machine learning in QDMR and WordStat. WordStat is the main software to do machine learning. So I will try to show you both how you could do machine learning um, from from QDMiner, but this some of the thing that I will show also apply if you are running WordStat through Stata or SimStat. So I will first give you a short introduction to the machine learning, actually to automatic document classification, but it's a misnomer somehow. The thing is that we could do more than classify documents with machine learning, and so I'll give you a short introduction. And I have to say that what I will do today is not all type of machine learning. We generally recognize two broad types: unsupervised and supervised. Unsupervised would be doing things like topic modeling or some technique that will extract information without any guidance as to what the software should look for, while a supervised machine learning is actually something that is guided by some classification. So we'll be focusing on that. I think we did present something on topic modeling before and how to extract topics automatically. And so I'll start by giving you some principle, and then showing you how this is done in QDMiner from QDMiner. And the different ways one could implement machine learning using WordStat, and how you could also bring back some machine learning models that you created in WordStat into QDMiner. Okay. Now, if I have to categorize what is machine learning, let me just activate my PowerPoint. So basically, what you do is that you need to have some documents that have been categorized, and you feed the software. Well, if you feed the documents to a machine learning algorithm that will actually look at the documents and look at how words in it are associated with different categories, and it will try to then identify classification rules that will then allow you to take documents that have not been categorized, and that it will apply those rules in order to guess which category it belongs to. Okay, so we will see how this could be done, and typically this is done using so here we have documents, and for each document we have some variables. So for example, if it was a customer review, we could have a ratings that we want to predict, or a sentiment, positive or negative, that would apply to the full document. And in this case, we have speeches, 243 speeches, and we know that we have several candidates, political parties. So we could try to predict any one of those outcomes by looking at words, how different people are using different words, or how words are used by different political parties, and try to come up with some prediction. Okay, so that's one way to do it. But there's also another way when you combine it with QDMiner, is that you could actually take the coding itself. So here, rather than analyzing the full documents and looking at how it is related to some variables, you could look at how the text differs depending on the coding you did. So you could select some coding, and then you could ask your software to try to identify different rules, and then you could later categorize text based on those rules. So you could come up, implement that in QDMiner, and come up with some rules. And I will explain to you why this ability to do a machine learning on coding could be interesting, and how it could improve results of classification. Okay, so let me actually go back, and I'll do this from now on from QDMiner, and I will start it by showing you how I could categorize text, develop a machine learning that will predict either the candidates or the political party. Okay, so I will go and I will call WordStat. And what I want to analyze is the text. So I will select the speech itself, which is in my document variable. And I will put here as the other variable in relation to it, the two variables that I want to predict. So I could do that on candidates. I have 10 candidates. I can do that also on political party. Okay, and I use those two examples in my case to show you how we can do that. And I will use, we are working on WordStat 8, but I will show you this on WordStat 7 now. The features are quite similar. So it won't affect a lot. So here, WordStat allow you to do several things. It allows you to apply dictionaries, but typically machine learning will often be done without any dictionary. So for example, here if it would categorize all items into 4 categories, it is typically too restricted to come up with some good classification. So what I will do is I will simply disable that, and I will, here I could select some words, and here I have actually 300 words only. Typically for machine learning, especially when you have a large amount of categories, I tend to use a lot more words, and yet I tend not to include words that occur not too frequently, only once or twice. But for example, here if I select words that occur 10 times and keep a maximum of 3,000, I should get probably 2,000, 3,000 words. Okay. Yeah, I do have 3,000 words, and the less frequent one is 10. And so I have 3,000 words, and I could try to predict on that and try to come up with some, see whether I could categorize either the candidates or the political party. So let's start with something easy. Let's start with the political party. So so I will go into WordStat. By the way, I could have used a dictionary to maybe put some words together. And for now, I don't use any stemming and lemmatization. I will come back to that. I could have done that, but for now, I'm using the raw words without any lemmatization or stemming. Okay, so what I will try to do, okay, so if I want to do classification in WordStat, I have to go to the classification page, and I have to select the variable that I want to predict. And what I need then to choose is how I will test and validate my machine learning. And there's a few ways to do that. First, what I could do, and typically this is one way that is being done traditionally, is to have a training set of document on which I will do my learning, and then I will have a different test sets on which I will do my testing. Okay, but if in this case, what I will do instead is I will actually use my original data set, and I will actually split it so that I will actually do the learning and the testing on the same data sets. And to do that, what you could do is that you could actually split your full data sets in by 5. So for example, I have almost 250 documents, so it will be about 50 documents each grouping. And I could actually now the 5-fold cross validation. What it will do is that it will take 4 of those groups, so about 200 items, and it will try then to test the models, predict on those 200 on the 50 ones that are remaining. Okay, and then it will do that by removing each group of 50 documents one after the other. So it will basically develop 5 models on about 200 documents and test it on 50 documents. So that's one way to do that. But I could also create divided by 10 or divided by 20, and that will actually develop 20 models, test it on items that have not been part of the learning set. So that's one way to do that. But if I push it further, I could actually leave one out. So basically what I do is here I have 243 documents. I will actually develop 243 predictive model, each time removing one document, develop the model on 242 and try to predict this one. And I will do that 243 times. Okay, and this is when you have a small training set. So you try to use as much information as is possible. So I will try to do that here with the leave one out, and let's see what we get. So the first thing the software will do is that it will go through all the documents and see how words are associated with different parties. Okay, so this is where we have a list of all the words that we call here features. And I can see that, for example, college is very highly associated with democratic. They are sorted actually from the chi-square, okay? And those ones are identical here. It's not always the case, but in this case, it's the exact same thing. But college is used more often by Democrats. Starts is used more often by Democrats. Ronald is used more often by Republicans. Well, you may have guessed that the color is not the color of the political party. It's simply in red is the one that is the class that is being predicted. Okay, and I think I could set it so that, let me see. Yeah, so here, if I click on that, it will actually keep Republicans and Democrats in a specific order. So I could see that how one of them is predicted. So basically, I will try to predict on that. I could remove some words there, or I could actually compute this statistics differently, either by looking at whether it occurs or not, how frequently if it occurs, and if I do that, it will recompute it, and I will come up with different numbers. So by doing that, it found that Bush actually was the best predictor, predicting that they were Democrats. Actually, this is from the 2008 presidential race. So Democrats were mentioning Bush, and Republicans tend to mention Bush less often. Taxes was mentioned more by Republicans, and Reagan more by Republicans. Okay, so the software could actually try to, based on the fact that some words are used more than one or the other, they could actually predict more one party than the other, and that's what we will try to do. And what I will do is I will go now to the learn and test feature, and this is where I will choose which method that will be used. For now, we will use all 3,000 words. So what I will do is I will use a naive Bayes approach, and I could have different settings. So I could simply try to see whether they use the words or not weighting each feature. So the features typically, I can simply say whether 0 or 1, but I could actually weight them by some other metrics. But for now, let's simply try to see how it occurs. The thing here is that I have more speeches. I think I have more speeches by Democrat than Republicans. And if I do a simple naive Bayes will take into account this. So it may, in course of uncertainty, it may actually predict if it's a Democrat. So what I don't want this, so I will tell the software, okay, don't take the prior probability into account, don't take the prior distribution into account, and in course of uncertainty, the software may actually don't know whether it's a Democrat or a Republican. So I often use this when I have an imbalance data sets. Now I could clearly, quickly do a quick run, and I can see that I did achieve, in terms of precision, 91%, almost 92% accuracy. So basically, the software here was able to predict at 92% whether it's a Democrat or Republicans. It made some errors. Okay. Now, what we have below is the actual. It's a confusion matrix, so it tells me what is the actual classification and what was the predicted result. So what we can see here is that we have 156 documents by Democrat, and in 152 times out of 156, it actually predicts that it was a Democrat, but in 4 times it predicts wrongly that it was from a Republican. While here I have 87 speeches by Republicans, 71%, no, sorry, 71 of those were predicted as Republicans, and 16% were predicted as Democrat. So we can already see that it's actually easier to predict Democrat than Republicans. Republicans tend to be, some of the speeches tend to be categorized as Democrats, and I could play with some settings and try to come up with something better. And I can also see that, for example, I have 16 and 4, so it's 20% to 20 incorrect classification out of 243, 223 that are okay. And I have some percentage here that tells me that I predict accurately 97% of the speeches by Democrat. I only predict 81% of the Republicans, okay? In terms of recall, when I retrieve something as Republicans, it is 94% of the time correct, while it's 90% of the time correct when it's a Democrat. This is more the recall, okay, of the Democrat, okay? So from there, I could also see what type of errors there are. This is quite similar to what we had before, but in a different way, because it will be sorted. It will allow you to sort them, and when you have many categories, it will sort them by the most frequent ones. And I could actually review what are the documents themselves and why they has been categorized as Democrats or Republicans, okay? So, but what I did here is simply trying to categorize based on the fact that they use the word or not. What if I look at how often they use it, okay? So what I could change it to keyword frequency, and I should look at this number. It will go from almost 92%, and if I use the frequency, it goes up to about 2% more, okay? And I can see that I still have more difficulty explaining Republicans. And I could look at the percentage of words, and I could change that. Now I'm at 96%. And the thing is that I know that I could actually probably weight each word by different factors. And if I weight by IDF, now it goes down, okay? So, and I could weight by something else. Chi-square goes up. Max chi-square, if it won't change, because that's the same thing, okay? So I could play with that. And I could try to come up with what would be the best predictor. And by working on the settings, I could increase that to maybe 98, 99. I know that I think I've been able to go to above 98%, close to 99. But there may still remain some errors. So here I could go back, review the error, and try to see, for example, this one. Actually, I can see that the predictor score are quite close, so they were close call here, almost all of them, because you see the probability for each of those categories are very close to each other, okay? So that's by playing on the type of settings that you use to measure and to predict classes. You could come up with different results. You could also come up with different results by selecting features. And I could, because I know that using all features is not necessarily the best way to come up with a good model. I may be able to predict with only 1,000, and I could select from here using different techniques. And typically, let me select, yeah, I have 3,000. Let me select 1,000, and I will select on the global chi-square. And we have a optimization technique here that will try to optimize and make sure that we get good predictions. So if I go down, I'll find items, let me go down here, that are not selected. And now I could go back, and on 1,000, let me select, yeah, that was the one that was giving us 97%. Then I will try, and I'm almost at the same, yeah, I'm almost at the same kind of prediction, but with 5,000 words only, okay? Now, it could be quite time consuming to select features or add words or delete words automatically, and then work with all those options. So what we did is that we created something that allows you to automate this process. And I will show you how to do that. and I will go there under history, and you see that I have some results here. Okay, and but I can also click. If you click on this button, you could actually create a series of experiments that will be listed here that will allow you to test all the different options that are available. So let me actually do some of those settings. Actually, this is actually the number of words that will be selected. So let's go up to 3,000. Okay, and okay, so I could set some options here and add them one by one. But an even better way is to use this that will allow me to basically, and again, those ones when I have only two categories are redundant, but I can actually select items like that. And if I do that, again, I won't select this one. I have 54 settings, different settings, combining different technique based for the learning and for the rules that will be applied later to classify. If I do that, it will do this 54 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 54 by 12, click on that. It actually created all those experiments, and I can now optimize a machine learning that will, and I won't let the software do all of this, but you will see quickly that it will come up with some results, actually. Okay, and it creates some curves. Okay, and what it does here is that it actually testing different models, and this is the accuracy. So I know that I can see that some of them, even with 200 words, can get pretty high accuracy. Okay, and let me stop it there. Okay, and if I go back to the table now, I can sort, and I can see that I've been able to achieve almost 97%, but I could do it with only 200 words. And if I double click on that and run it, now I can replicate the results, and I can now save that as a model file that I could use. And I did reduce the number of errors, 3 and 2. Okay, so only 5 items have not been correctly categorized, and now I can save that. Okay, so naive Bayes is actually a technique. To give you some background about naive Bayes. Naive Bayes is a technique that takes the probability of a word being used by different categories, and it will actually multiply all those probabilities of all the words that you feed in the model. But the thing is that it won't take into account either the sequence of the words or the co-occurrence of the words. So it treat them independently. We say if it's a kind of bag of word approach. So that's the reason why some people say it's naive, is that because it's a naive assumption, yet it often gives good results when you can optimize it. Okay, now I will save it. Okay, so if you click on that, and I will say, okay, Democrats or Republicans. Okay, so I save a model on disk. Now I can use that either with QDMiner, or I could also use that with the WordStat classifier, which is a small utility program that is available with WordStat. Okay, so but let me also talk about the KNearest neighbor. KNearest neighbor is a different technique. It's no longer looking at probabilities of words. It's actually look at similarities of documents based on the words that they contain. And again, I could do the same thing, only take 200 words or maybe 3,000 words, and I could again try to predict the model. But what I have to do is I have to tell the software how many documents the software will compare. So basically, in order to do a KNearest neighbor, okay, with the leave one out technique, and let me do, say, for example, 10 neighbors. So what the software will do is that it will actually take out of 243, 242 documents. So it will take out one document. It will take this document, and now it will compare it with all 243 242 remaining one, and take those, the 10 most similar ones based on the words in those documents. Then it will look at whether if it comes from a Democrat or Republicans, and if there are more Republicans than Democrats, then it will consider that it's probably for Republicans, and if they're more Democrat than Republicans, it will think it's a Democrat. That's how KNearest neighbor works. So if it will do that for every document, comparing with the 10 most similar documents, and guess the categories based on the number of similar documents that fell into that fall into each of those two categories. So let me do a very quick one here. It's on 200 words, I believe. So it did come up with something okay, but again, more problems predicting Republicans. Okay, so you could try different machine learning. Well, those are the two that we provide. But if you could test those two, try to see whether you could optimize a model and come up with a good prediction. Now, I have to mention the fact that I could have done several things. For example, well, I could have tried to predict the candidates, and the candidates could be much more difficult to predict because by chance, and let me do it here, by chance, it will actually, I have 1 chance out of 10 of guessing right. So for example, okay, jihad was used more often by Romney, and then by Richardson and Biden. Settlements here is used more often by, is used only by Biden, so it predicts that it's Biden. There are some spelling mistakes or some proper names that I should probably, that will be almost cheating keeping those. Typically I should remove those, but Tennessee, for example, that would be Thompson. Shiite would be Biden. Sunni, Biden, but then Kucinich. So again, we could do the same kind of learning, and let's do that on our 3000. I think that they are still connected, and let me try to do a naive Bayes. Again, keyword frequency, and let's do this. Okay, so I had 1 chance out of 10 of guessing right, but the software was able to predict at 83% the correct candidates. I know that I could bring it to more than 90% if I let it run and try to optimize it with some items, but here that's for the purpose of this demonstration, it's not necessarily relevant that I optimize it. But what I want to point out is that, okay, I often say to people that, okay, stemming, typically when you do either exploratory text mining, unsupervised machine learning, where you try to extract topics, I don't recommend to do stemming. Yet, stemming could actually increase the performance of machine learning in some situations. So you taking a large number of words is one thing, but you could even also do stemming or maybe try lemmatization instead, and both of them may actually help you increase the results of the machine learning. And if it works great, and if it does increase your results, the accuracy of the prediction, then why not do it? There's even a technique that I often use, which consists of letters and grams. Okay, so basically I could decompose a word, and let me show you. I'll do that. So here what the software will do is that it will decompose every word into a sequence of 4 letters, including the space before and after. Okay, and I will end up with something that doesn't look at all at words. Okay, so we should, okay, so that sequence of 3 or 4 letters. Okay, and what I will do now is I will try to see whether I could predict the candidates, or let's try to do that on the political party. Okay, now it has to convert the text, apply machine learning on those sequence of 3 letters, 4 letters, and if I do a quick test, for, let's keep these settings, I may get actually not a good prediction here. Actually, how come I have so few cases? I have probably no prediction for those. Let me go back and I'll try to predict the candidates. Let me make sure that I don't have a filter here. Okay, so now the software, yeah, I should have removed the exclusion list, but okay, so I have some items that are associated with different candidates, and if I do a learning sets, let me make sure that, let's do first a keyword by frequency. Okay, I'm at 65. Again, if I try to do this by chi-square, I'm at 77, and I know that I could probably bring it quite high. One interest of this transformation, actually, I think I was able to bring it at more than 85%, even by if I'm not looking at words. One of the value of that is that it could help you come up with good prediction on social media or any kind of text that has not been spell checked. Is that if someone make a spelling mistake somewhere in the word, the software could still match part of the beginning and part of the end. So the software could actually give some partial points based on some part of words. Okay, so we have found that doing a machine learning on sequence of letters could actually predict without making any spelling correction. It could actually give good prediction even on poorly spelled documents. So again, quite often people in machine learning will actually try different things, and if it comes up with good results, even if it doesn't seem to make sense of simply analyzing a sequence of letters, for example, or then anyway, if you can come up with a good prediction, that's something that could be of value. Okay. Now I did save a model on disk. I want to go back and show you that since I save it on disk, now I can use it in KNearest to do some retrieval, because we have, for example, I could retrieve text, and I could either retrieve documents, and let me retrieve all the documents. And of course here I would not typically do that on this data set, because that's the learning set. Or the training set, but if I was looking for to predict the political party, I could retrieve documents and I could try to predict and actually to call a predictive model, a classification model. I have to click on that and select the model. You see that I created this. Now it's available here, and I could tell the software, okay, I want to classify all those documents at the top. And let me put a ratio of 1. Ratio of 1, it will actually show me all classification. But if I click a ratio of 2, it will simply look at, and of course, it did predict most of the Democrats as Democrats, and it may have made some, yes, still. Okay, Republicans, Democrats, you see, okay, of course, that's easy. But if I was doing that on maybe sentence or paragraph, then I could actually categorize paragraph based on whether they are likely to have been said by a Democrat or a Republicans. And again, let me do something like that. It will actually look at the ratio of the highest and second highest values, and it will only bring when the ratio is twice the probability of being a one class is at least twice the second most likely class. Okay, so that's what this ratio does. Okay, so I show you now how to apply a machine learning in KNearest, and from there, actually, I could actually categorize the documents based on whether they have been mentioned by a Democrat or a Republican. Okay, and clicking on that, it will actually create 2 new codes, Democrat and Republican, and attach tags to almost all, actually not to almost, to all paragraphs, depending on whether they are if that's been predicted as a Republican or Democrat. So this is how you could do a apply machine learning in QDMR to automatically code. But if you try to categorize based on the full document, okay, of course some people may mention things that are more similar to what people from the other party are saying, but remember that I told you that I could actually use the coding that was done here, a manual coding that was done, to do some machine learning. And let me try to do some machine learning here. But first, let me look at the frequency of the codes. Okay. So I have housing, taxes, healthcare, national security, and Middle East. So let's try Middle East, healthcare, and taxes. Okay. So I could try to predict whether they are talking about those 3 items. And to do that, what I need to do is I need to call the software and say that I wanted to predict, okay, I said middle class, healthcare, and taxes. Now let's do housing crisis as well. So 4 categories. And if what I have to do also is tell the software that I want to compare across codes. So here in relationship, the assigned code or category. So what it will do is that it will extract everything that has been tagged as housing crisis, taxes, healthcare, Middle East. Click OK. Again, I will call WordStat 7. And I will, let me simply look here. Okay, I have 200 words. Let me increase that. I will do again, go to 3,000. I tend not to include low frequency words. 10 should be, at 10, I have 1,739 words. And if I try to predict the code, actually, let me show you that I could actually see that I could do a crosstab by the code, and I could actually see that if I do a correspondence analysis, those 1,700, so for example, those words would predict the housing crisis, those words would predict the Middle East, and I could actually predict the taxes using those words and healthcare using those words. So, but of course, this is not necessarily the way to do it. I will go there. I want to see how it is associated with the codes. And again, let me do a pretty quick test. Simply whether a word occur or not. Again, I have 1 chance out of 4 to predict right. Let me make it uniform again. I may have more code from some. I'm at 69, almost 70%. Again, I could look at the frequency of the words. I could weight it by either IDF or percentage of words. Or chi-square. And I'm now at 82%. I could go on like that, and again try to experiment with more words, etc. And the thing is that once I have a model that allow me to predict that, then I could save it and use it to maybe categorize or retrieve items that are associated with different categories, in order to tag them. So if you do some machine learning, some manual coding, and you have a training set where you have code a lot, but you have a huge amount of documents that remain to be coded, you could probably develop something that will allow you to find those. I did not include the remaining text. So I had the option of including the remaining text. So I would have 5 categories actually, and one of them would be uncoded or the remaining text. So that would be also a way to make sure that I won't force one of 4 categories, but it could actually also predict that it's neither one of those 4. Okay, so that would be one thing that you could do. Now, one thing that I wanted to mention is that, and let me quick WordStats here. One thing that I wanted to mention also is the question of sentiment analysis. Okay, sentiment analysis is something for which machine learning could be used quite a lot, and sentiment analysis is very popular. What we did found is that if you use a lexicon approach, your lexicon approach will be to build a kind of dictionary like you could do in WordStat. You could build a dictionary of positive words, negative words, with rules that take into account negations or modifiers. and you could come up with some results. And if you don't customize it, we found that typically you could get maybe 70–75% accurate sentiment prediction, trying to predict whether it's positive or negative. And it goes, if it could be below that, we've seen some lexicons that would actually predict only 50% with 50% accuracy, which is barely, well, actually that's not different from flipping a coin. Okay, if you try to simply to predict positive or negative. Okay, so with a lexicon, you go with uncustomized lexicon, you could go from maybe 70–75. If you customize it, we found that if you could spend some time on that and a couple of days, maybe a week, and you could actually bring it quite often to 80–85%. And that would mean removing words in lexicons that are associated with your domain that are not predicting the right sentiment, and but also adding words that are specific to your domain that predict positive or negative sentiment. Now, if you do machine learning, typically, if you have a training set, and that's the condition, you need to have a training set of items that have been predicted, then you could easily come up with something like 90–95% in minutes. Okay, and also in terms of bias, we found that machine learning will be less biased than any lexicon approach. But there's an issue if you want to train, and let me try to see whether I could find a data sets. Okay. If you are doing a survey, I will bring a data set I have here. It won't be long, where we use. Let me see. Okay, I will do. Okay. Okay. So this is a data set that come from Amazon reviews. It's actually 20,000 beauty products, and what we did is that we have a for rating, and what we did is that we remove actually, yeah, I should probably case filter out, ignore, and let me show you. So what we have is we only have ratings of 1 and ratings of 5. So here I have some data sets where users rated themselves their comments, so we don't have to ask people to rate them. And we could try to predict whether if it's a 1 or a 5, and that would allow me to come up with some good prediction. Okay, and that's what we did, and we came up with something like 93–94% accuracy very quickly, surpassing any lexicon approach to text. But there's an issue is that sometimes comments will be mixed, and that's the reason why it is interesting to be able to actually tag documents, so that, for example, if I think that this is actually positive, I could actually create a code that will be, okay, let's put positive under sentiment. Had. Okay, I close that. Okay, great, fine. We use it again. Let me actually create another items here, and I could actually go there, and if they also mention things that are negative, so I could have in a single document something that is positive, but maybe something else, and I will do that somehow randomly, and I will call it negative. And now, and let me actually change the color here. Okay, and now everything I will, for example, can go wrong. Love the consistency, so that's positive, and I could go on like that. But when I have long documents, I could actually identify what brings me to think that this is positive and this is negative. And quite often people will have something to say. They may have a kind of mixed review, but if you are simply using the overall score, the software will include some noise and may not be able to do a machine learning that will be as accurate as if you are actually tagging the section that is associated with the different outcomes that you want to predict. So by combining the manual tagging with the machine learning, you could come up with something that is actually better in terms of prediction. Okay, so I don't want to take too much time. I want to keep maybe some question if you have some questions. So if I will let Tony see whether there's.
Yes, Norman, we have one question to start.
Okay.
Is there a limit for the amount of words within a document if documents are analyzed for similarity? I'm thinking about witness statements, for example.
Okay. I don't believe there's, well, we haven't encountered any document that could not be compared, because typically the software will take a long document and it will actually add a large amount of words. Although, if you have only large amount of words, the occurrence of a word may not be as good predictor as the frequency of the word or the percentage of the words. Percentage of the words will take into account the fact that you have documents of different sizes, for example. So you may have very short documents and very large documents. If you take the frequency, that could be problematic. But if you take percentage, that would be a situation. But in terms of number of words, I don't think there's any, we haven't encountered any limit. And if there is one, then some people have encountered that they didn't mention to us.
Okay. A quick follow-up on the same question, and then we'll move on. But is there a limit for the amount of documents where machine learning on QDA Miner or WordStat, so documents where would not be effective anymore?
Do you mean for the limit in number of documents that WordStat can process, or because WordStat can process hundreds of thousands, if not millions of documents, but of course, when it's millions of documents, the software could have some issues with memory. We are actually working in the version 8, should be able to analyze many millions of documents and be able to do machine learning on that. Although, when you have that kind of size, what typically you would do is that you will split and you will do, if you don't have to do a machine learning on a million documents, you could do that on a sample, on a random sample of 10,000 or 20,000 or 50,000, and that would be good enough. And then you could classify the rest if they have not been categorized initially.
Okay. When would using WordStat be better, or for machine learning than when would QDA Miner be better to use for machine learning than WordStat?
Actually, QDA Miner cannot. Well, it has some machine learning inside, but it's not. Part of it is part of the. And let me show you. We have what we call find similar, and the software will do it kind of. It's a supervised machine learning, but with starting with a single example, and you could say, okay, this is good, and maybe this is not good, and you could actually come up and create a kind of training sets. But QDA Miner won't create a model that you could save on disk and reapply. WordStat is really the tool that will apply both naive Bayes and KNearest neighbor in the way they are typically being applied, and will allow you to save a model.
Okay. Are there a minimum number of documents to use machine learning to get proper results?
Yeah, that's a tough question. Well, of course, one document won't work. You need at least 2 documents for 2 categories. And would it work? It may even work on two documents, and being able to predict something else if the documents are good enough or representative enough of this. So but of course, the more documents, the more text you have, the better it is in terms of training sets. So it's not an easy question to answer, because, for example, you give me 100-page document, 200-page documents from 2 different, say, political parties, and I may be able on that to create a model that would predict something else. Although I won't be able to do a leave one out or any cross-validation technique. I would have to use an external data set, because of course I cannot remove one or 10%, or because I have only two. But of course you need more documents, at least as many as you have categories to predict. And if they are pretty small, the chance that you will get a predictive model that will be robust and that will allow you to predict will be quite small. But typically, again, the more example you have, the better it is. And if you have long documents and you actually tag those documents, the sections of the documents, actually you don't have 2 documents. You may have 500 examples, because you may have attached tags, 250 tags for one topic or for one prediction, and 250 tags for the other prediction. Although you start with two documents only, you actually have 500 training sets. Okay, and they become like document by themselves.
Okay, next question. What is the significant predictive value for the naive Bayes test?
I don't think that we outcome any probability when we do machine learning, and I think this is, yeah, the group would be this. But the thing is that typically you should make sure that in terms of prediction, you actually get you get something that go beyond chance. And again, if I try to predict 2 groups and I come to a 50% prediction, I'm pretty sure that it's not significant. And typically, I should be way above that, way above the random, so that significance testing would no longer be relevant. If you can predict at 90% or 95% something that you have only a chance 1 out of 10, like I had for the candidates, I can be more confident that I can be quite confident that what I'm predicting is good. But of course, I need a test sets that would be significant. If I only do that on 1 sample, being able to predict accurately this one is not necessarily relevant. If I can predict 100 different documents, that's much better. Okay.
Okay, this is a little complicated, but I'm sure. Okay, when the classifier is trained on text within documents that are tagged in QDA minor, does the trained classifier, when applied to uncoded documents, then categorize detailed text in the documents?
Okay, let me see. Okay, so you could use. You could develop a machine learning based on tag documents, and I hope the person will tell me whether I answered the question. So you could actually do a training based on the coding you did on some documents. Then you could actually, there's a way to filter documents that have not been coded, and then you could actually retrieve all paragraph from those uncoded documents, and then apply the machine learning to actually code all the remaining ones. Although you have to be careful, you have to look at the confusion matrix that you see when you develop the machine learning, because some items may be very difficult to predict or even impossible to predict. I've seen situations where we were trying to develop machine learning models and we could barely go above chance. And when you do that, for example, if you do that for a couple of categories, it may be easy when they are very distinct categories, but the closer they are, the more difficult it will be to predict and come up with a good classification. Yet the thing is that QDA minor will allow you to, once it has been coded, will allow you to revise them manually, so you could go back and change the classification done by WordStat. And that's also another value of a manual coding tool, is the ability to adjust the learning by going back and changing the prediction by changing the tag associated with the document that has been assigned by a classifier.
Okay, I hope that's what she's looking for. But Kim, if that's not, if you need a follow up, or if that's not what you were looking for, let me know.
Okay.
Have there been any studies that have compared something like LIWC to machine learning?
I don't believe so. Because the Luke or LIWC has been applied for many kind of prediction. And I remember quite a long time ago they did some. They were trying to do lie detection with the Luke, and the way it works is that you apply the dictionary, you come up with some classes, and they develop a model that try to predict something. My guess is that, like any lexicon approach, machine learning would likely come up with better prediction. But that's an assumption I made. I am not aware of any comparison involving the Luke or LIWC and machine learning.
Okay. Kim said the other one, your answer before was quite helpful. Thank you very much. Okay, another question here is, it's about, I'm sorry, I'm scrolling back to get it because it was asked earlier. Does Provalis provide detailed documentation of the machine learning capabilities of WordStat and QDA Minor? If so, where could I find it?
Actually, we document well. The technique we use are pretty well known. It's not. There's no black box here, and there may be a few things that are slightly different. For example, Naive Bayes well known, KNearest well known, and the manual will describe them. I hope they describe them in details. I'm pretty sure they do. Yet if not, you could still contact us for some technical question about how it is done. But we could also give you some reference on some text on machine learning that explain the basic principle behind Naive Bayes and KNearest neighbor. We may add in the future other classification model. What I know is that the way we did the Naive Bayes and KNearest server, the way we implemented those, and the fact that we have this experiment button, we were able to test many models of Naive Bayes and come up with prediction that were better than some of the newer algorithm like SVM, support vector machine. We were able in one situation in the competition actually to get better results than SVM, simply because we could test thousands of models during the same time that they could only develop one or two SVM prediction. So, but the experiment is basically should be based on a manual, self-explanatory. The fact that you could actually compute different statistics differently, and that you could weight words differently and come up with different results. And all of that, like the confusion matrix, is also pretty standard in the way we did that. If there is something that is not as obvious or doesn't seem to be as normal as what you should see elsewhere, then contact us and we will try to explain that to you. Okay,
I think our time's up. Thank you very much, Normand. There's a couple of other sort of similar questions to that, and as Normand said, send us the questions. The best place to send us the questions to get the quickest answer is support@provalisresearch.com. We usually get back to you within an hour or a couple of hours if you send something there. So for those type of documentation questions that a couple of you have, that are still sitting out there, if you want to send those questions to that email address, we'll get back to you. Thank you everybody for attending. We're going to try to do these webinars at least once a quarter, if not more often. We're a little busy with a lot of things right now, but we know that people like them, and we want to do more of them. If you have any suggestions as to things that you'd like us to cover on these webinars, please send them to contact us on the website. Again, thank you very much for attending. and other webinars that we are going to have, we'll announce on our website, on Twitter, on our Facebook page, and also in our newsletter for the different times and dates and subjects of those webinars. So thank you very much. The recording will be up on the website probably near the end of the day, or if not, first thing tomorrow morning. So thank you very much and have a great day.